Hi all. In today class, we are going to discuss how does the ECG machine has been made. Okay, what are the generalized blocks which has been involved in making ECG machine. Okay, so let's see one by one. So as we discussed already, to measure the ECG, we should follow any of a 12 lead ECG configuration. That could be lead 1, lead 2, or lead 3, or AVR, AVL, AVF, or chest leads. Okay, so these are the option we are having to measure the ECG machine. Okay, so this is the patient. We are using any type of available lead configuration. So first we have to place the electrodes, and to connect the electrodes we need lead channels, and as a continuation of electrodes we have a lead channels. On the one end will be connected with the electrode, other end will be connected to the machine, right? So these are going to be the lead channels. Okay, so next we will have the major block, that is its defibrillator protection circuit. The reason of introducing this defibrillator protection circuit is, for example, if the person is monitoring their heart rate with help of ECG machine, in the meanwhile there is a need to have some defibrillator shock. Okay, all of a sudden the patient has undergone some cardiac arrest. There is a need to give any defibrillator shock. So in that case, this high shock, it should no way get interrupt with ECG machine. Okay, how we can protect this high shock in the sense by means of this adding defibrillator protection circuit. This defibrillator protection circuit will prevent this passage of high voltage shock, high frequency shock from entering into this machine, so that it will not disturb the ECG machine. The ECG will give values, that is data of patient ECG continuously. So that is the reason to have defibrillator protection circuit. So not only the defibrillation shock, for any over high voltage shock, whatever the shock, that could be any leakage shock or anything. So this defibrillator protection shock will prevent all the kind of high energy shock, high voltage shock from entering into ECG machine, so that it will not disturb for any cause. It will give output continuously. That is the reason here they have added defibrillator protection shock. So second, you have a lead selector optional. As I said before, the ECG machine is enabled with so many lead connection, that is unipolar, bipolar. Under your bipolar you have lead 1, lead 2, lead 3, or unipolar 1 to AVR, AVL, AVF, and you have chest leads. So based on the need and demand, the doctors can select any type of lead configuration if you want to measure ECG of particular patient. Okay, you know the each and all the lead system difference and uniqueness. So again, based on the application or demand or need, or suggestion given by the doctors, you can use any type of lead connection. With the availability of this different option, we can measure the ECG monitors. So that is a lead selector which enables to select any type of lead at time of monitoring. And you have next, the thing is the calibration signal. Here the calibration signal will be the standardized 1 volt. The reason of this calibration signal, you know what is the purpose of having calibration. So if there is any drift in recording data, or if there is any changes you can see in the output, that drift and changes can be nullified by means of this sending this calibration signal. So you are making the device to be pakka state in order to ensure the correct output which is given by the machine. Yes, that is the reason we have this calibration setup in order to nullify all kind of drifters changes introduced in the device. Okay. Next, you have bioamplifier. This is the very important block. The reason to have bioamplifier is that whatever the data you are getting from the patient with the help of lead connection, all the signals are very weak in amplitude. Okay, it's a very weak signal. It is not enabled easily. It is not enabled to process easily in the next process. That is the reason here you have involved bioamplifier block, and this block is going to strengthen the signal. They're going to increase the amplitude of the signal so that it is more suited to be properly processed by the next block. Okay, so after processed, then you can display the particular ECG signal with the display unit, that is the output unit, or you can either record the unit, or you can have a written format also with the help of chart recorder. Okay, so this is the basic thing, basic blocks which are involved in ECG machine. So and then you have a CM, common mode reduction amplifier. The reason of including this common mode reduction amplifier is to reduce the interference. So as we are subjected into so many artifacts or movements artifacts or noise artifacts will be there, by removing, in order to remove these kind of artifacts, we need some kind of block to remove this. So that block is going to CM reduction amplifier. This reduction amplifier is going to reduct all kind of common noises which is existing in the recording data, as well as the interference or whatever is being imposed in the signal. Okay, so the most important thing is that power supply. In order to supply the power, all the subsequent blocks, that is important to be focused on that. That is a power supply. You have two types of power supplies here. They have included, one is the main power supply, another one is isolated power supply. The reason to have two separate power supply is to isolate the patient from patient end, to isolate the patient from machine end, and main power supply, so that if there is any leakage current from the main power supply, it will no way get affected to the patient, or if there is any leakage current from machine side, it will no way get affected by patient. So that is the reason, because the patient's safety is very, very important as far as medical device concerned. We have to design in such a way so that if there is any problem with main supply, it should not affect the patient side, either on machine or machine end or patient end. We should be very conscious, because the patient and also the operators or nurse or technicians will be operating. While operating that, by touching the machine, they should not feel any kind of shock. So their safety, the patient safety, not only the patient safety, whoever operating that machine also, that particular person concerned, we have to be very serious their safety also. So for this, as by considering all of the all safety aspects, we have to design the circuit so that we have a different two supplies, that is main supply, that is going to give on direct patient, another one is isolated supply, that is going to connect to the components which is being directly connected to the patient. And okay, so that's why for output, that is a machine end, we have direct power supply connection. On the blocks which is have direct connected with the patient, those blocks will be connected to the isolated power supply. So this is the isolation transformer and the isolated power supply, and then given to the blocks which is being directly connected to the patient, and direct power supply is given to the machine end where it shows the output. So this is the reason to have a two power supply, that is the isolated power supply. So that's all about the basic ECG machine blocks, the block diagram. So these are the major most important blocks, irrespective of any type of model or brand or any companies. If you take these are the basic things it's been involved in ECG machine designing. Okay, so maybe for future additional by adding any additional features or any unique features, if they have included, means the respective blocks will be added in their block diagram. Okay, so but other than that, this is the basic ECG machine block diagram. Thank you.